All right, let's take care of part B. We have x equals t and y equals t to the fifth divided by 10 plus 1 over 6t cubed. And let me just remind you the arc length formula for curves in parametric form. So we have only dx over dt and dy over dt needed to like write down this integral. So what I'm going to do next is just I'm going to go ahead and find dx over dt and dy over dt. But first of all, I should put before I start, I should put this in the power form. So this is 1 over 6 t to the minus 3 so that I can use the power rule for differentiation for y. So dx over dt is just 1. All right, so dy over dt is going to be equal to 5 t to the fourth divided by 10 plus 1/6 negative 3 t to the minus 4. Let's simplify that. So 5 over 10 is 1/2, so t to the fourth divided by 2, and then minus 1 over 2 t to the fourth. I took the reciprocal of t to the fourth, okay? All right, so let's write down the arc length formula. Arc length is integral from 1 to 2, and you have dx over dt squared plus dy over dt squared. Okay? And dt. All right, let's just expand inside the radical here. So you have 1 plus t to the 8th divided by 4 minus 1/2 plus 1/4 t to the 8th, because you take the square of the first term, that's t to the 8th divided by 4, and you multiply the first and the second term and then multiply by 2. But when you multiply t to the fourths are canceled, you have negative 1/4. And if you multiply it by 2, that's negative 1/2. Okay? So dt. All right, so I don't need this part. I'm going to erase this. Now I'm going to continue from the top with a different color. Okay? Here we go. S is equal to integral from 1 to 2. 1, well, you have t to the 8th divided by 4 plus 1/2 1 over 4 t to the 8th dt. Okay. So the good news is that the inside the radical is in fact a perfect square. In fact, it's the perfect square of t to the fourth divided by 2 plus 1 over t to the fourth. Like similar to this term, but there's a plus sign over there. You can sort of convince yourself. Okay, let me just put the dt as well. Okay, and I have also the radical here. All right, so let me just correctly write it. Okay. All right, so that term is simplified to t to the fourth divided by 2 plus 1 over 2 t to the fourth dt. So now my next task is to try to integrate the integrant. And I'm going to rewrite that in terms of the power form so that we can use the power rule for integration. Okay. All right, so t to the minus 4, here we go. So let's continue from here. So you have t to the fifth divided by 5, but you have another 1/2. So you have t to the fifth divided by 10. And let's just take care of this term here. So t to the negative 4 plus 1 in the exponent divided by the new exponent. That makes it minus 1 over 6t cubed. Okay, I also use the reciprocal. Okay, from 1 to 2. Okay, And at this moment, I'm just going to let you plug in the upper and lower limits and subtract from each other by using the fundamental theorem of calculus. And you should get down to 779 divided by 240. Okay. So the length of the arc of the curve parametrized like this over the interval 1 and 2. You get 779 divided by 240. All right. All right, this takes care of part B, and I think we're done with the whole question now, and I think we can end the video. Thanks for watching. I'll see you in another video. Bye.